Hello and welcome to this section of the MATLAB tutor. We're going to talk about generating vectors with random numbers. Sometimes you'll be running a code or writing a program or doing some problem where you need a listing of numbers that is randomly generated, and then you can use that random list of numbers to run through your code and perform different calculations. So there's lots of times when you might need the computer to actually generate random numbers. So MATLAB has a command built in for that, and you might guess it's called rand. Okay, now if you just type in rand like this, it's going to give you a random number. It's a single random number, right? So if you keep entering this command in over and over, it's going to give you a random number. I should say it's a random number between 0 and 1. And that's typically how it's all done with computers. If you need a random number between 1 and 10 or something, then you would just say random times 10, and then you would have a random number between 1 and 10. If you needed a random number between 1 and 100 or 1 and 1,000, then you would just multiply rand times 1,000, and you would get your random number between 1 and 1,000. So random numbers are easily generated in MATLAB. Now if you need to generate a vector with a list of random numbers, it's also very easy to do. Random, and you need to open parentheses and tell MATLAB you want a vector with 1 row and let's say 7 columns. So when you write things like this, the first number is the rows and the second is the column. So it's rows comma columns. So when you do that, you get a listing of 1, 2, 3, 4, 5, 6, 7 elements there. And again, if you needed a vector that had 6 random elements, you could do this calculation again and again, and you'll see each time you're getting different random numbers all the time. And again, just like before, if you needed a random vector, with random numbers between 1 and 10, then you would just multiply that times 10, and then every time you do this calculation, you're going to get a random number randomly generated between 1 and 10. Okay, so that's how you do that. Now, by the way, when I say random number like this, 1, 7. I'll just give you a little bit of a sneak peek. Right now we're talking about vectors, which are just sort of one-dimensional, one row entities. But you guys all know about matrices. We're going to get to matrices very soon. If in here you put something like 2, 7, or let's do 3, 7, this is the number of rows and this is the number of columns. So when you do that, you'll get a matrix, which will have basically 3 rows, 7 columns, and they'll all be randomized. So that's a very useful thing you might typically need to do to generate and to do that. So if you wanted to generate one instance of a random guy just to use in subsequent calculations, then you could say random 1, 4. So I'm going to generate a vector with 4 elements randomly, and I'm going to store it in a position vector. So then I can use the entity vector. I can use it in all subsequent calculations. It's randomized. That's fine. So there's cases when you might need to use that. Now there's other commands that you can use. Just in passing here, I'll tell you to generate matrices. One of them is one called rand perm. It stands for random permutation. Remember, permutation is basically a listing of elements where you can't repeat the elements. So if you do rand perm like this with 6 as the argument, in fact you can see MATLAB's trying to help us here. As soon as we put the parentheses, it starts telling you random perm parentheses in. So if you put a number in there, what's going to happen is it's going to generate a vector with 6 elements, 1, 2, 3, 4, 5, 6. So we have that guy, and when it generates it, it's going to generate a permutation of those 6 elements. So the ordering in this case is 2, 6, 1, 5, 4, 3. If I run the calculation again, I'm going to get another permutation, 6, 3, 5. You can think of these as lottery numbers, basically. This is almost like a lottery number generator. So rand perm is basically when you have occasion to create a vector that's a permutation of some numbers. So I could store it in vector 2, and I could say, okay, generate a random permutation of, the elements 1 to 10. And it will do that for me. It'll be random each time. When you would have occasion to use this, it depends on your particular problem. I'm just trying to give you examples of when MATLAB can generate these matrices for you rather than you having to go off and try to make up some numbers yourself. There are also a couple of other things that you may have occasion to use in your programs. One is if you want to create a vector that's initialized with all 1s, then you would have 1 row and let's say 6 columns. So you have to do the row comma column thing there. And you can see it's going to fill that vector out with all ones. So if you wanted to create a vector called initialize ones with 5 elements, the 1 here, by the way, is not because we're putting ones here. It's just that this is 1 row, 5 columns. So there you go. So now we have a vector with all ones. If I wanted to create another vector and fill it with all zeros, I put zeros, 1 comma 8. That means 1 row, 8 columns. And then I have a vector of all zeros, which are then stored in my vector test. So you might say, when would you ever need to do this? Well, it depends on your particular problem. Sometimes you need to have these initialized vectors there. Now, when you have 8 elements, it's not a big problem for you to just manually define it. But what if you have, a vector with, 266 elements in it, and you wanted to put zeros in every element, that would be a real pain in order to type it in there. So you just create the vector like that. Now I put a semicolon to suppress the output because the real output looks like something like this. Zeros for all of those elements. Okay, so now I've cleared the screen, and what I want to do now is just kind of show you, even though this is kind of dipping our toes into the next couple of sections on matrices, but a minute ago we were doing things like ones and doing 1 comma 4. That's creating a vector with basically 1 row and 4 columns. But much like I showed you before, this is going to extend itself to matrices. If you wanted to make a 4 by 4 matrix of all ones, then you just put 4 rows, 4 columns, and then you have your matrix. The same thing applies to starting a matrix with all zeros in it, the same way we've done here. Now, I want to close the section out by showing you how to sort a vector in ascending order. Sometimes you have an occasion to do that. So if I have a vector, let's just say, we'll call it vector R, and I have a bunch of different values. I can have -88, 0, 2, 5, 2.5, -4, something like that. So I have several values in here, right? And then for whatever reason, this is raw data that I've collected. Maybe I'd like to sort it in ascending order. So there's a function for that, sort R, and that's all you have to do. Hit enter. This does not store anything back into the vector. It just takes the output and it sorts it in ascending order. So if you were doing one of those random permutations or something, I'll say vector y equals random permutation 9 elements, let's say. Then what's going to happen here is I've generated a vector with 9 elements with random ordering of the elements because it's all random permutation, right? Well, if I take sort and apply it to what I've just done here, then it should take the output and rearrange it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are these elements rearranged in ascending order. So this is useful when you have a lot of data you're pulling in from some file, and then maybe you want to sort it in ascending order for whatever reason so that you can look at it, so then you could apply the sort function to that. I hope this section's been useful for you. Go off and play around with it yourself. Make sure you can generate these vectors and let MATLAB do the heavy lifting for you when you need to generate a vector of random numbers or permutation of numbers or something of that nature.